Okay, nice to meet you. I'm Olivier. As my little French accent should denote, I live in France, and I've started to play, to be honest, with Pravega 2 years ago. I discovered it through a Flink presentation, and I wanted to try to make some connector for Alpakka, which is Akka Stream community project. So we will show you some advances on this topic. This is the fast agenda. I just take the time. I will quickly present Akka Stream, Alpakka, and a little part of the general Akka Stream API, and of course the Pravega connector, and a small demo, and perhaps we can talk a little bit about what we could do tomorrow. First of all, Akka. What is Akka? Akka is a main actor library of the Scala ecosystem, and also Java, of course. And to be very simple explanation, Akka are just actor are just objects that are part of a hierarchy with a notion of supervision. That means that an actor has a parent and child relationship, which means that the life cycle of the children are handled by the parent. It can cover the error cases, or also creation and deletion. Actors are communicating only by message passing. So there is notion of mailbox tied to each actor, and that's it for the actor. It's a quite common pattern. I think everybody has heard about it. Akka Stream is a streaming library built on Akka. It provides type-safe streaming. Of course, I will explain what is it. To be, it's the Akka Stream defined, not of course every streaming API defines this concept. Some of the building blocks, source, sinks, flows, and many others. They are highly composable in the sense, as you can. Do you see my mouse pointer? I don't know.
Yeah, we can see that well.
You can see it moving. Okay, so you can group together a source with a flow and with another flow, and building a composite source like this, or many other composition, of course. And Akka Stream main benefit is to provide back pressure for free. You see, it's quite simple to use. And when I say highly composable, okay, you can also compose the composition, of course, and this is recursive and has no real limit. So the end, you obtain you have to provide a runnable graph, which is a closed shape, okay, which can have a source and an end. Alpakka is the project. It's an open stream initiative, an open source initiative, which provide many patterns of streaming, some transformation utilities, and of course some connectors. There are now about 20 or 30 connectors. It's intended to be the camel of Akka Stream. I think that everybody knows about camel, and of course the Pravega connector. So, from my point of view, what is this connector? It's just a source that can consume on the topic stream from Pravega, or a flow that can write to Pravega or read from Pravega. So, just to illustrate the composition of the library, when we want to provide a stream, not a stream, a sink from a flow, it's very easy. You have a flow, you add a sink which ignores the input, and then from a flow you build a sink. As a very simple example, I will show you how to implement a source, a number source, which obviously is a source that provides integers from 1 to overflow. It's I don't go. First of all, it's a real code. Okay, it's not a simplification. So this is the whole code you have to provide to make a source. So it's a source. Why it's a source? Because it has a shape of source that produces int. Everything is typed. There is the notion of outlet. Okay, because a source has an output. And there's many other details, and the implementation goes in this function. This function is just there, and it's nothing more than having an initial value and react every time somebody asks you for a new value. You push the value and increment the counter, and that's all you have to do to make a source component. Of course, and then Pravega is no more than using the Pravega API to provide a source and a flow. So I will show you a very simple usage of the API. That's a sync, so a way to write into Pravega. Okay, that's just a thing. So we can go. I don't know. Too much time. So we can go very simply into the API. A sync is with this function. We provide a sync from a scope and a stream name via a flow. That's what the simple I was giving. I gave a few minutes ago. A flow that we ignore the output. So the flow, you can see the same code as the int generator. Of course, the logic of producing the result is quite different. It uses the API of Pravega and some semaphores to handle the velocity of the connector. So I close this, and this simple usage is there. Okay, I will generate a sequence of number from 1 to 10 in this example, provide a string, and write the string in the sync. So if everything works smoothly, so I didn't start my shells. You see the shell? Hello?
Yeah, we see your terminals.
Is it
yeah, building SPT in both, yep.
Yeah. Okay. So in this very, when I run for the demo, the writer, which is this code, okay, sorry. It's just read, it will print out the names from 1 to 10, and the data are put in Pravega. So if I build yes, so then there is a stream with 10 values. In the same way, you have to write a reader from a reader group. That's where I understand very recently how we're working reader groups. And this is as simple. From a reader group, you read a source, which will be, a source of string. You can see in the type, which is a source of Pravega event containing strings. And of course, if I hopefully run the reader, a good one, this one, it will read the 10 events, and I can of course provide more events. they will be read again. Okay. Close. So this simple demonstration of how to write and to read from Pravega. Of course, there are many more usage than using pure string. And just to play a little bit, with Akka Stream API, I implement this workflow. Okay. This time we have two streams, A and B. So two sources, a merge component that merges the result of the two topics. After that, I broadcast in two pipes. One pipe that do nothing, the other pipes that will make a lookup in a Alpakka VP table to retrieve a value if it exists, and zip the result of the two substream in a tuple, so key value pair, string and the count, and update the count in the key value table after that. Okay, so here I have a name 1, name 2, the input I showed you just before. In broadcast names for every record, of course, they will be broadcast on the two pipes. Name 1 and return the count there, and after I increment the count in the table, and that I will show you how to implement this in Akka Stream. As we will see, it's very funny. I find this very funny. And the end result is a stream of tuple, name a string to int. Is it clear?
Yeah, yeah, it is for me.
And if you want to, this is in ASCII art. You may think the representation of this workflow. In fact, not. It's not an ASCII art. It's real code. It's real implementation. As you can see, there is a quite perfect match with the drawing and the code. Okay, I have sources, merge component.
Olivier.
Sorry.
Hey, just one quick question. So this lookup component here.
I will show you.
This is an operator.
No, I will show you just
Pravega symbols. Okay.
Okay,
I'll hold on to my question then.
That's no problem. So as you can see, there is a good match from the specification and the code. I show you the code that isn't for that. This is what the PAP. Okay, you can see the screenshot I took for to implement and to make the slide, in fact. And your question is there, lookup. It's a flow. I've made some helper method, of course, because it's not very funny. It's just a Pravega table with flow to a scope, table and family extractor. It's the API of KVP table, I think, and I will explain more how it works. And first, you declare all your components independently, and then you attach input and output of inlet and outlet of each component to produce source. Okay, so this is a composite source that will produce tuples from the string and the count of the string in the Pravega table. Okay, that's it. Lookup. The lookup will just make a lookup in the table. If there is no entry, I say it's the first one I encounter this entry, or else I increment the count. And after I update, same way. Read through. It's very every time the same thing. In fact, read through, and that produces that receive a tuple and let it pass downstream. And if it won't work, it will be nice. So I have to run this reader. This is waiting. I think, and I send here 5 messages in bstream. They arrive there. Up again, 5 messages in A-stream. And it stops because I wanted just to listen to wait for 10 messages, 10 tuples. And of course, if I run again, this time I send 10 messages, so there will be sent to up 1 to 10, not 1 to 5, and up. There's a new count. I already consumed 10 messages. Okay, so. And of course, they arrive in certain order. The value after 5 are just 1, and that's it for the small demonstration of how work this API of Graph, those implementation. In near future, I need to stabilize and clean up what I've learned from Pravega API. Because at some point I done some mistake, mainly because I knew Kafka and I thought it was the same kind of API. I need to see how to implement something with transaction checkpoint, as it's quite complicated, in fact, because streaming and transactions are not so easy to implement. And I will probably do the same things that Think with the checkpointing. I'd like to know also what to do with the property of Pravega to dynamically scale the partitions. If I can use this in Akka Stream with some substrings temporary, I don't know. And of course, I'll provide an API because for the moment it's quite raw. And that's it for me. Do you have some questions or remarks?
You kind of blew my mind that ASCII art was executable.
Excuse me, I can see you. Where is the screen? I lost the image. Okay. You said? Sorry. I didn't get you.
Oh, I just said I was really surprised that the ASCII art was actually executable.
Yeah, that's nice. It's because of Scala. Because Scala has the ability to redefine operators, and it's just method calls, in fact. Okay, and with infix syntax. So when you see what is very handy to use, that this, if you see the overline, it's a source, okay, of the string. I have 2 source of strings that I merge in a fan from 2 string from one string. After it's a fan, it's a broadcast operator and things like that. Okay, it's a flow to int. Okay, because I ask to the KVP table the value, the int value from the and also and zip component also, which sorry, it's takes a stream of int and a string and produces a stream of tuple, and this one the shape the component will write back to KVP table. In fact, it's just they are just objects. Okay, there. And the method exists. Sorry, I can see I should should, I don't know. My editor is not. But it's just a method call, in fact, with the infix syntax. But that's quite. Of course, when you write in Java, you cannot use this syntax. It's clearly more verbose. But it's okay also. The connector is you can use this connector with a Scala API or Java APIs, of course. It's mandatory for Alpakka. That's it.
Hey Olivier, I have a couple of questions. Can you go back to your last slide?
Of course. Last one.
Yeah. So a couple of quick questions. Yeah, exactly. So that one. Yeah, this one. So when you talked about transactions, you said that this is quite complicated. So I assume you're saying this is complicated on the Akka side. So what is the complication you're referring to? I'm just curious about that.
Okay, for me, it's just complicated to know where to start the transaction, where to end the transaction, because streaming is infinite. So what is logic? Where can I start end the transaction? I have no idea of how to implement this. In fact.
So Akka has no notion of say checkpoints or snapshots or anything.
No.
Akka doesn't have that notion.
No, as far as I know, no. It's not. It's just a planning API. Okay, you have to implement your own logic.
Okay, so that was one question.
I don't know.
Second one is,
I know it's
for the third bullet, scale with
some
dynamic
discussion
importation.
about this.
Does Akka have any mechanism for scaling a workflow?
Some tooling. My connection is unstable.
Oh, it sounded like he wasn't able to hear you.
Did you? Okay, so let me repeat the question. Sorry. So for the third bullet, scale with dynamic string partition, I am one. So I was thinking when you mentioned that, I was thinking about how to do it. And my first question is, or my question is, does Akka provide any mechanism for scaling a workflow?
Yes. There are many. You can change the parallelisms of operators. Okay. So I imagine I can listen to. I have some mechanism to listen to Pravega partition scaling and react on my part to multiply the parallelism.
Yeah, this sounds like a great one to follow up. I mean, this is great. We should discuss this more offline.
Exactly.
Oh, thanks.
Thank you. And there is also a component, two components that are merge hub and the other part, the broadcast hub, which has some kind of hub. You can add some pipes dynamically. Okay, you can you at runtime you instantiate a graph and you attach it to the hub. And I'd like to talk about this. Okay.
Yeah, let's do that. I think it's a great topic to follow up.
Thank you.
Yeah, the mailboxes in Akka are basically in-memory queues. They call them mailboxes. Any other questions? That was really great, Olivier. It was cool to see key value tables in action so simply.
Thank you for the demo.
Yeah.
Thank you for Pravega.